Go, a lesson on power theorems. Specifically, these are theorems involving lines and circles. I'm going to leave it really generic by lines because the lines are going to be different types of lines. In my first example, we have two chords. All right, so we call this one intersecting chords theorem. If two chords intersect, then the product. What does product mean? It means multiply. The product of the parts are equal. What do I mean by the parts? Okay. So this piece times this piece is going to equal this piece times this piece. In symbolic form, we would write VE times EN will equal LE times ES. All right? Intersecting chord theorem. So they're going to give you problems like this. Find X, okay? Most of you can see that the X would be 4 in this case without doing a lot of math. Always make sure you show me some sort of reasoning how you got 4. Second of 3 is called the secant tangent. So notice in our diagram we have a tangent and a secant. The tangent, by the way, starts from there to there. The secant starts from there. These lines continue on, but when we refer to them here in the theorems, we're referring to just those segments. So the tangent in this case is the geometric mean of the secant segments. What does that mean? All right, I've kind of drawn it out there, but PT squared. Now you may ask, why is it squared all of a sudden? Because I'm taking the same distance twice. There's two parts. Will equal that part times the whole part. So in this case, it would be PQ times PR. All right, so in this case, we can see then, remember how we defined geometric means back in the day? When something squared equals the product of two other pieces. So therefore, PT squared is equal to the product of those two pieces. And again, they're going to give you problems like that. So, y squared is equal to 32. Don't forget to simplify your ratios, all that good stuff. Yeah, so y is equal to the square root of 32, or y is equal to the square root of 32, which we all know is 4 root 2. And we can ignore the negative here because these are positive distances. Theorem, the last one, is called the secant-secant segment theorem. And here again, this is the secant-secant segment theorem. So this says if you have the external part, TU, times the whole piece, SU, will equal the external part times the whole. Okay? So in this case, it would be UV times UW. And the way we write that out is we say if two secant segments, if you have two secant segments, then the product of the external part and the whole parts are equal. All right, well, hopefully the problems look, something kind of along this lines. This is obviously a secant tangent problem. Be careful when you do them, set them up properly using one of the 3 theorems that are introduced to you. Secant-secant, secant-tangent, chord-chord. Best of luck.